See this problem. A point charge plus 10 microcoulomb is a distance 5 centimeters directly above the center of a square of side 10 centimeters as shown in figure 1.34. What is the magnitude of the electric flux through the square? Hint. Think of the square as one face of a cube with edge 10 centimeters. Our motive is, here a square is given. So above that square, if you draw a line to this plane, and the line seems to be normal to the plane, and 5 centimeters above the plane you are keeping a charge q. So this is perpendicular. We need to find out the flux which is passing through the square due to this charge. That is our motive. Now come to the investigation part. The charge q is equal to plus 10 microcoulomb, that is equal to 10 into 10 to the power of minus 6 coulomb, and the distance of the charge from the plane D is equal to 5 centimeters. So 5 into 10 to the power of minus 2 meter, and the side of the square is equal to 10 centimeters, that is equal to 10 into 10 to the power of minus 2 meters. And I am considering the epsilon naught also. Epsilon naught value is 8.85 into 10 to the power of minus 12 coulomb square per Newton meter square. Now come to the resolving part. The hint is given. Think of a square as one face of the cube with edge 10 centimeters. So for us it is given that a plane, the side of the square is 10 centimeters, and if we assume another 6 planes which constitutes a cube like this with the same dimensions, and assume that the charge is inside that cube. So using this hint we need to find out the flux. If you see here, the side of this each square is 10 centimeters, and here also it is 10 centimeters, and you are keeping the charge which is above the plane at 5 centimeters distance. That means it is exactly center of the cube. Then the flux which is coming out of this charge will be equally distributed over the surfaces of this cube. So that means the flux, whatever the flux that you are finding for the charge, is written as q by epsilon naught times, and this is the total flux for each phase. Now for one phase it will be 1 by 6 times of this total flux. So phi a is equal to q by 6 epsilon naught, because all the flux coming out of this charge is equally distributed through this 6 surfaces. So the flux which is passing through square can be written as 1 by 6 times of q by epsilon naught, that is equal to 10 into 10 to the power of minus 6 divided by 6 into 8.85 into 10 to the power of minus 12. So if we simplify this, you will get 1.88 into 10 to the power of 5 Newton meter square per coulomb. So this much flux is flowing through that square.